Can you see the screen?
Yes, sir.
Okay, thank you. Okay, today we are going to do revision. The last time we had class, most of your classes we are clashing with other class for the degree students. So last time we had physical class, we did some things and we solved some of the things we did. Then the last one is on the online class that I have to give you material to read ahead and explain through this our platform. So in those things that we did, we were not able to solve. But why I called for this revision class is to know the areas you are finding difficult and be able to give you some solutions to what we've done in the last class. Are you following me?
Yes, sir.
Okay. So, like the last time we did inductance, and this formula you are seeing here, I hope you are seeing the formula, was given. And I believe you should know that we use it to find the inductance of an inductor. And just like this question, what is the inductance of a circuit whose frequency is 75 Hz and inductor value of 270 millihenry? Inductor is a form of opposition to the flow of current. But this opposition to the flow of current depends on frequency. Are you following me? In the last class that we did online, I explained it, but these were theoretically, we didn't solve anything as per mathematical aspect of it. So, looking at the questions and resolving the questions, we have to state the formula for inductance, which is small j x subscript L, and is equals to 2 pi fL. This is in what we did in the last class. And in that last class, you will see where they wrote WL. The W is 2 pi f. We did this 2 pi f in class. I showed you how we got the 2 pi f to be omega. So we have the frequency given to us as 75 Hz, and we have the inductor value as 270 millihenry. Then when we apply this formula, we know that pi is 22/7. Then we put our frequency 75 Hz and put our inductor value, which is 0.27 Henry. When you convert this milli, it's going to be 0.27. When something is in milli, it means that you should divide that in by 1,000. When something is in micro, it means that you should divide that in by 1 million. Are you following me? When I say are you following me, you unmute your mic and talk.
Yes, sir.
You can mute it back.
Yes, sir.
So when we input these values, what we got as this inductance, this is an inductance, is 127.2857 ohms. If you look at this place, you will see where I wrote reactance. Why I have to cancel it is that this one is particular to inductor. But when you have inductor and capacitor in a circuit, that is when you attribute reactance. It's a combination of inductor and capacitance. That is where you say that we have reactance. All of them are opposition to current. While we have resistance, we have reactance. But in this particular circuit, we are talking about inductor, and we have to call it inductance. Are you following me?
Yes, sir.
Okay. So this is another question. This is another question. What is the value of an inductor in a circuit with inductance of 250 ohms and 65 Hz of frequency? So it's just mathematical manipulation. we just list out the values they have given us and what we are looking for. Here, we are given the inductance, which is 250 ohms, and we are given the frequency. Then pi. This pi is a constant, which is 22/7. Are you following me?
Yes, sir.
Okay. So we now impute it. We now impute it again. We have Jx of L is equals to 2 pi FL. But what we are looking for is L. So we make L subject of formula. So it will give us Jx of L over 2 pi FL. So we put our values 250 divided by 2 times 22/7 times 65. And we have 250 ohms divided by 408.4070. And what we have as the value is 0.6121 Henry, or you say is 612.1 millihenry. This is another question. This question is a combination of everything we've done, both the reactance, both the sinusoidal, the one we did in class. The impedance of a circuit is Z. Z is what we use to denote impedance. When you see this Z, we use it to denote impedance. And impedance is a combination of resistor and reactors. Reactive elements are inductor and capacitor. Are you following me? When you combine them in a circuit, what you will have is impedance. The only difference between impedance and resistance is that impedance is a resultant of resistance and reactance, and it depends on frequency, while resistance does not depend on frequency. So if you look at this place, you will see that this is 80 ohms minus J75 ohms. This 80 ohms is representing the resistor, while the minus J75 ohms is representing the reactance. Reactance is the combination of inductor and capacitor when they are found together in a circuit. Are you following me?
Yes, sir.
Okay. So they now told you to find the current, the power factor, apparent power, real power, and reactive power. Then equally told you to find the voltage drop across resistor and the voltage drop across the inductor and the capacitor. And they gave you the input voltage as 240 volts at an angle of 0 degree and frequency of 50 Hz. So what you will do is that you list those things that you know. And what are the things that you know? We have that V in is 240 volts at an angle of 0 degree, frequency of 50 Hz, resistor, the value of resistor as 80 ohms, and the reactance to be minus 75 ohm. Sorry, just supposed to be in front of this 75. Then we have that I, we are told to find I, we are told to find the power factor, which is PF. We are told to find the apparent power, S. We are told to find the real power, and we are told to find the reactive power. We are equally told to find the voltage drop across R. We are equally told to find the VLC, but we are given the impedance in a Cartesian form. This is a Cartesian form of impedance. So before you start solving, you have to convert this impedance to polar form. And this is the Cartesian plane for the impedance. Let me go back. This is the Cartesian plane. And in this Cartesian plane, you will see that JXL is at the uppermost part, vertical. We call this side, I hope you are seeing my mouse. We call this side the vertical, the positive side. We call this down one the negative side, where the capacitor is. Then this horizontal line is the resistor. So the vertical line is called the imaginary plane, while the horizontal line is called the real plane. So these two things are vector, both the vertical, the one pointing up, and the arrow going horizontal. They are two vectors, and they are crossing each other. The combination of both of them is what is giving us impedance, making an angle theta. So why I have to write this 75 here is that from the formula, from what they gave us here, this impedance, it means that this minus shows that after combining the two resultants, these two, JXL and JXC, we have the remnant being at the negative side, which is more capacitor. It's more capacitive than the inductor. So we have to put it here. This combination of vectors. I know you people did vector summation. Okay. So let's proceed again. Impedance in polar form will be, you use Pythagoras theorem. And what is Pythagoras theorem? Okay. The Pythagoras theorem states that the square of the hypotenuse, this is the hypotenuse of an angle, of a triangle, because this is a triangle, is equals to the square of the adjacent plus the square of the opposite. And this one, R, is the adjacent of this angle, and the opposite is minus J of C. I hope you people are still here with me.
Yes, sir.
Okay.
Yes, sir.
So when you solve it, the square of 80 ohms is 6,400. The square of 75 is 5,625. So you now say square of Z is equals to 12,025. Then Z, when square crosses equal sign, it turns to square root. This is just plain mathematics. I don't need to be telling you the reason why it turned to square root. Are you following me? That's the reason you are taught mathematics. So when you do square root of 12,025, you have 109.6586 ohms. And this ohm is what you are going to use to find your current and other things you are going to be finding. Then you now get the angle theta, this angle here, this angle theta here. And what you use is the normal thing you know, SOHCAHTOA. This is just plain mathematics that we are doing, which is tan theta. And why is it tan theta? Tan is TOA opposite, which is this one here, over adjacent, which is R. Which is now 75 over 80. We have 0.9375. Tan theta is equals to tan inverse of 0.9375. And we are having 43.1524. But because this angle is at this negative side of the Cartesian, the angle will be negative. We put minus in front of the angle when you have found it. So when I found this thing, we now put minus 43.1524 degree. Then our impedance in a polar form is 109.6586 ohm at an angle of minus 43. 0.1524 degree. Then we will now find our current. A current is equals to V over Z. The same Ohm's law you know very well. I know you did EEC 115. So they taught you Ohm's law. Ohm's law states that the current passing through a circuit or the current flowing through a circuit is directly proportional to the voltage across the circuit and inversely proportional to the resistance of that circuit, provided that temperature remains constant. So in this case, we are not talking about resistor only, we are talking about resistor and reactors. So, and when we combine both of them in a circuit, we have impedance. So we now have it to be, our voltage is 240 volts at an angle of 0 degree. Then our impedance is 109.6586 ohm at an angle of minus 43.1524. Perpetual, you should control your phone. So when you divide this, we have 2.1886 ampere. Then this angle has its own rule of division or summation. By a mathematical principle, when an angle is dividing an angle, you subtract the denominator from the numerator. So in this case, this division will change to subtraction. And already the denominator has negative sign. So minus 0 degree minus 43.1524 will turn to positive. So in this case, current is leading a voltage by 43 degree. What I mean by leading is that current is ahead of voltage. When you draw that sinusoidal wave, if you draw both current and voltage, you see that current will be ahead of voltage. Voltage will start with 0 degree, but current is going to start from 43 degree ahead of voltage. So then power factor. The power factor is equals to real power over apparent power. Or you can say resistance over impedance. Or you can say is equals to cos theta. Let's fall back to that Cartesian plane. In power factor, or when you say draw the power triangle, in the power triangle, this R is the real power, which is P. Z is the apparent power, which is S. And this vertical plane is the reactive power. Sorry. Is the reactive power. This thing should go up. So this one is the reactive power. I don't know what is wrong with this. So when you combine them in the circuit, you will have that this resistance over impedance. And when you use your SOHCAHTOA, resistance is at the adjacent, impedance is the hypotenuse, and is equals to cos theta. Likewise, the real power and the apparent power. So our power factor is equals to, you can decide to say cos 43.1524. It will give you 0.7295. Or you can say that our apparent power is equals to 80 ohms divided by 109.6586 ohm. It will give you the same value. Or you can find the real power and apparent power. You divide it, it will still give you this value. But in this case, Are you following me? Hope you are hearing what I'm saying. The meeting will be ending soon. I will be posting another link for you immediately. Okay. So in this case, what you should do is that since we have our impedance and we have our resistance, you just do 80 over the impedance. You have your power factor. It's very simple. Then you are told to calculate the real power. These are the formula for real power. Voltage drop across resistance times current. We know current, but we've not known the voltage drop across resistance. Or you use the square of current times resistance. So we know our current, we know our resistance. Or you use the square of voltage drop across resistance divided by resistance. We only know resistance here. We don't know this one. So I decided to use the one we know their complete values, which is I squared times R. And we have 2.1886 ampere square times 80. It will give us 4.79 times 80, and this is our answer. Real power is measured in watts. So this is 383.2 watts. Then this is the reactive power. The same formula applies to reactive power, which is voltage drop across the inductor and capacitor times current, or the square of current times by the reactance, or the square of voltage drop across this inductor and capacitor divided by reactance. And our reactance is minus J75 ohms. Are you following me? So we choose this one, this second one, because we know our reactance and we know our current. And when we fix it, we have the reactance value, the reactive power to be 359.25 voltage ampere reactive, VAR, voltage ampere reactive. Then apparent power, which is square of current times impedance, or the initial, that is the input voltage times current, or input voltage square over impedance. Or you say that is equals to P square, real power square, plus square of the reactive power. Or apparent power is equals to real power over cos theta, or you can say real power over power factor. We use this one. Later, you will try all these other formula. They will still give you this value. Are you following me? So we use this one, which is 4.79 times 109.6586. This is the value it gave us. We use that of the cos theta, and it still gave us this value. To be sure of what you got, okay, let me call the value for you. We got here 525.2647 voltage ampere. Then we say that 383.2 divided by cos theta, and cos theta is 0.7295. It gave us 525.2913. By approximation, they are equals to 0.3. Then the voltage drop across resistor, we have it to be V of R is equals to current times resistance. And our current is 2.1886 ampere times 80. We have it to be 175.088 volts. The one drop across inductor and capacitor is equals to 2.1886 ampere times 75 ohms. And we have it to be 164.145 volts. I think this is the end of the class.